Now it's time for us to derive the formula for the sum of an infinite geometric series with first term a and common ratio r. So over here, you can see we have an infinite geometric series that goes a plus ar plus ar squared, and it just continues forever. Now we're going to start off by calling this whole series S. So now we're going to introduce a new series. But what should this new series be? Well, the new series that we're going to bring in is going to be our original series multiplied by the common ratio. So that would be r times s. Because when we do this, we're going to be taking each term in our initial series and multiplying it by r. And when we do that, we're going to get a new series with many terms in common with our initial series. So here we would get a times r. To start off, that would be ar. Ar times r is ar squared. And it would just continue. Now it's time for us to get rid of these common terms. How did we do that before? I'm sure you all know by now. We can do that by taking the difference between these two series. So s minus r times s would give a. Because all other terms just go away. From here, we can factor an s to get this. And now from here, we would just divide both sides by 1 minus r to find s. And we would get this very familiar looking equation that many just memorize, but you don't have to, because now you understand where it all comes from, so you understand how we got here. Now there is one important restriction, and that restriction is the magnitude of the common ratio must be less than 1. Now don't worry if you don't understand this. We're going to be going over this in depth in another video. But for now, it's just good enough to know how we got here and understand how we got the formula for the sum of an infinite geometric series. So don't just memorize it, understand where it comes from, because if you ever forget the formula, well, you can always do this all over again.